All right, good morning, everyone. Thanks for your time here on Thursday right before lunch. I'm glad everybody got the memo about personal space and really spreading out uniformly. We're already well ahead of the game. My name is Daniel Bounds. I'm here to represent AMD. I run our data center marketing for our EPYC line of processors. I always do this quick check. Many of you can harken back to the days when AMD had close to a third of the market from a data center processor perspective. Saw declines after that and actually stepped away from the data center business for a number of years. If you're in this room, you probably already know we're back. And we're back in a way that we believe is bringing a great deal of meaningful innovation and change to the market, and hopefully it's something that you can unpack. But the other thing that I imagine you're thinking at this point, turbocharge your infrastructure with AMD EPYC processors. It's Microsoft Ignite. And Daniel, you're coming here and you want to talk about chips. And so the first question that I had as I was thinking about this is, when is a chip not just a chip? And that's when we design it with partners like Microsoft, when we think about what the capabilities are, not just today, but into the future, and what at the microprocessor level we can enable, what we can impact. And so we began with a handful of partners as we thought about bringing EPYC to market. Microsoft was at the top of that list. And we wanted to make sure that in the context of not just infrastructure, but applications, also emerging trends in infrastructure. I'll talk a little bit about the application of HCI with AMD EPYC processors. We wanted to make sure that we were designing the right chip to enable the entire ecosystem, to match the level of innovation that hopefully you've already enjoyed 4 days of hearing from Microsoft in areas where they're doing it in software. There is a tremendous amount of technology and innovation that's baked into AMD EPYC that, in point of fact, you can't go anyplace else and get. We've not just begun from a partnership perspective, so we have a rich history back in the Opteron days, not just from a technology and instruction compiler perspective, but also making huge inroads in terms of implementation of Opteron and Azure, and in many ways that laid the foundation for what we're doing today with EPYC as we talk about the full range of instances that we've worked with the Azure team to enable. The other thing that is super contextual to the way that we think about this partnership and where we're going is looking at it from a segment perspective. So if you rewind the tape to 2017, AMD gets back into the market. We do it with a 32-core processor. We've never had 32 cores. Been in the industry 20 plus years, have never seen anything like what AMD EPYC in its first generation was, but it was in its first generation. And I know a lot of you and a lot of customers across the landscape have looked at EPYC as, is this in it for the long haul? Is this the right set of technologies? Are these cores the cores that we've come to expect and enjoy from a data center perspective to deliver the performance that we need? My hope and what the market is telling us is that the answers to all of those questions are a resounding yes. And in point of fact, where we are today with our product line is now in its second generation. The code name is Rome. We tend to name our products after Italian cities, which sometimes is good, especially when you get to go and actually launch the product. But we designed it for 3 particular areas, which is no surprise. It's the bulk of the market. We have lots of customers today that are looking at on-premise deployments. Most of this is driven by application affinity and application performance. I'll unpack in just a minute some of the key features that set AMD EPYC apart. But in reality, across the board, whether it's I/O, whether it's memory bandwidth, whether it's core scaling or core performance, you cannot find a better solution from a hardware perspective, now enabled through software, than those that are based on AMD EPYC. And then, of course, working with the likes of the Microsoft Azure team to develop not just mainstream platforms, HPC-tuned instances, as well as memory-tuned instances, I/O-tuned instances across the board. There's a huge amount of flexibility that you get as you look at the capabilities of AMD EPYC, and I want to talk a little bit about that. But before I do, let me reintroduce to you second generation EPYC. EPYC is a processor by definition designed for the data center. The core itself is second to none from an overall performance perspective. And in point of fact, when we looked at the type of performance that we were able to demonstrate in the launch time frame, so this is about a 2-month-old product from a generational perspective, across the landscape. Of course, HPC. HPC is one of those areas where, for example, with HB2, we're seeing amazing performance on simulation apps, weather simulation, computational fluid dynamics. That's all about memory bandwidth, memory addressability, size and scope and capacity of memory, paired with a huge amount of cores. But we also saw amazing Java performance. So the core itself took a big jump forward as we moved from first generation to second generation, and across enterprise applications, the playing field really changed and shifted. And that's before we get to the idea that now we can pack up to 64 cores in a single data center chip. The architecture itself, I mentioned Zen 2, it's also taking advantage of a leadership position in the industry with not just a 7-nanometer process node, but also the ability to configure that and package that in a way that gets us to the 64 cores in a single chip. I'm not going to talk a huge amount about this, but you'll hear me say from time to time, AMD EPYC is the only processor on the market that actually changes the game when it comes to a single socket system versus a multi-socket system or 2 and above. Because you can get 64 cores in a single chip, because you can get all the RAS features, because you can get the memory bandwidth attached to each one of those cores that you could in a 2-socket system, it is a tremendously compelling value point as you're thinking about your hardware infrastructure. It also is an incredible savings in the context of looking at balancing licensing cost with overall cost to deploy your hardware. And that really leads us to the last piece, which is whether it's software licensing, whether it's the physical acquisition, or whether it's just the management. Because in point of fact, as we reduce the number of points of management, we actually reduce the overall administrative overhead that's associated with this. Second generation EPYC, in many ways, is what we believe to be a new standard. For many years, and again, I'll bet many of you outrank me in terms of years in this industry, but the reality is the CPU side, the hardware side of our industry has been on a very slow and steady cadence. You can set your watch by it. 10, maybe 12% performance gains, generation over generation was absolutely the standard. That actually makes it a lot easier to skip a generation, maybe 2 generations. Maybe you postpone a refresh cycle within your infrastructure for just a little bit longer, and that's great because the ultimate value is not there. As we moved from first generation to second generation, moving from a 32-core part to, at the top end, a 64-core part, but now the whole idea that a 32-core part is in the lower part of your stack really changes the way that you can think about this. We more than doubled the performance, not just of ourselves, but of the competition in 1 generation. You couple that with the innovations that I mentioned with the single socket, with a third more memory bandwidth, and as software architects, this should create a new paradigm of what you can do with the scaled out infrastructure. And so we're very excited about the possibility of not just on-premise tuning at the application level, but also pushing that out, seeing what it can do in the context of the public cloud, attaching to the wide range of Azure instances that are out there and creating a hybrid world that really takes advantage of all the resources that we're bringing to bear. From a technical perspective, it's the guts of the product that actually make it so incredibly important as we architect clusters and infrastructures around it. I mentioned the fact that performance and scalability significantly increase because of the way that we can pack double the performance in the same physical space. Or said another way, we can provide the same level of performance at half the power consumption. That's the power of having process node leadership and the power of being able to deliver up to 64 cores and 128 threads in a single physical package. And doing that without a multi-chip module, doing that all in a single chip. For hardware designers, this is critical because now I can do more with the board. Now I can do more with the physical space. Multi-core efficiency, again, the packaging is so critical here because it allows us to get way past the constraints of what others are having to do with monolithic die configurations. Throughput has been a hallmark since the launch of EPYC. So you've got data, you've got a great, powerful core to go and process it, but that is, a CPU does not make a system. And so throughput is absolutely critical. AMD EPYC right now is the only x86 server CPU where you can get PCI Gen 4 today. And the ecosystem has rallied around us. And there's lots of opportunities to take advantage of that, whether it be with storage, networking, or in the case of a heterogeneous compute environment where you've got GPUs that you just want to feed very, very quickly and efficiently. Throughput is also a function of the memory infrastructure and the fact that we lead the industry in terms of not just capacity per CPU, but memory bandwidth. We were at a third physically. We're at 45% as we go to higher stepping memory speeds. So at the top end of the stack, that really is all about maximum performance. At the lower end of the stack, it's about finding the right configuration that really unlocks the capabilities that you need at a much, much more cost-effective level. And then the last thing, and this is an interesting one that, this is where a lot of questions usually come in. AMD as a practice has put security as, in many ways, number one, right? You would expect performance. Performance is in our DNA, but security has certainly become a massive, massive imperative in the way that we design our microarchitecture. Equally important, how we think about the feature sets that we enable. So if you're representing or if you're a part of a small, medium business and you don't have biometric scanners and people shredders at the head of your data center, if you're not fully protected from a physical perspective, only AMD EPYC is the processor of choice that allows real-time encryption of memory to lock all of the intruders out of the critical data that you have stored in your memory. If you're deploying at the edge, if you're putting a more robust platform out from an IoT perspective, only EPYC has the capability to fully protect you from a memory perspective. We then extend that to the virtual environment where we encapsulate virtual machines and enable you to not just secure those with a unique encryption key that only that end user has access to, but also you can move that system fully protected between clouds. So a very robust security infrastructure is something that's already built into AMD EPYC. So just to recap, 64 cores. I just have to say that. It is a paradigm that for those of us who cut our teeth, I started at Compact Computer in the early days of ProLiant. Dual core was awesome, quad core, it's hard to believe it. And now we're talking about 128 threads in a single socket. That's pretty amazing, it's pretty powerful. And doing it in a way that doesn't forsake the overall throughput of the system is something that we think is a capability that unlocks value for you. Leadership in I/O, the ability to not only run 128 direct attach full bandwidth. So again, you're not having to make any compromises here. If you're building a accelerator box, you can take advantage of the 128 lanes at full bandwidth. No second chip required, but doing it at PCI Gen 4 speeds, double what you can do today with PCI Gen 3. Now, I actually hate this bullet. Full disclosure. So yes, we design up to 225 watt TDP, But the reality is most of our processors operate well below this. In point of fact, with one exception, and there aren't that many SKUs in the AMD stack, the whole purpose of bringing EPYC to market is to do something that is dramatically different than what the competition is bringing out there, to provide total flexibility and simplicity of stack. The only thing you really have to decide as you're contemplating how EPYC fits into your infrastructure is how many cores do I need? How much horsepower do I need? And ultimately, do I need a 1-socket or a 2-socket? Everything else, every other feature is enabled across the board, and we don't charge you more to go and do that. So we provide ranges from 150 up to 225, really in the sweet spot of air-cooled capabilities. And then we have one SKU that goes above that and typically goes into a more HPC-oriented water-cooled environment. So we're very excited about what EPYC brings to the table. In point of fact, there we go. When we look at the top end of the stack, 3.4 precision boost across 64 cores is pretty killer. This is a level of scale and capability that we've never really seen in this industry, so we're very proud of that. So let's talk about how this stacks up to the competition. As you're making a buying decision, as you're making a design decision, one of the ways that I know we enter this conversation is what's the integer and floating point performance. And before I get into this, the graph does not look terribly different whether we're talking integer or floating point at this point. But what we're showing on the left are publicly published data on the Intel Xeon stack. This is 2 sockets enabled. And up to their Platinum series, which can range anywhere from $10,000 to $17,000 list price. They're achieving a score of, I think that's 381. Yeah, that's right. With AMD EPYC, we're able to best that well into our 32-core stack. So mid-bin in our processor stack, we started 18. In point of fact, we've got 16 and 24-core varieties, just a couple of SKUs in there in case that's a sweet spot for you. But at 32 cores, we're kind of well above 381 at 431. And then, by the way, we've got 48-core and 64-core variants as well. Now, you can imagine that if we took a price performance view, which I didn't want to go there in this conversation, but I wanted to leave you with the idea that if you're maximizing for performance, and it doesn't matter if you're at the top end of the stack or if you're maximizing to the top end of their stack or even in the middle of their stack, imagine the level of scale that you can get from deploying multiple AMD EPYC systems and getting drastically more performance. I mean, even one-to-one, it's not even a competition. But look what you can do as you try to drive lower and more cost-effectively inside and up the stack. So that's 2-socket. The other thing that's really important is this idea of, for the first time in the industry, you don't have to choose a 2-socket server. We are not in the Henry Ford model of servers anymore where you can have any color car you want as long as it's black, or you can have any server you want as long as it's 2-socket or above. No. You can choose to have all the capability without compromise in a 1-socket system. So now you don't have to pay us for 2 chips every time you buy a server, but you get the overall performance. You exceed the overall I/O bandwidth of the system, of a 2-socket system. You exceed the overall memory capacity, and you essentially have a very balanced system that in many ways, so what's different here is the right-hand column here is AMD EPYC with 1 socket, with 1 chip. The middle column is Intel with 2 chips. That's their latest and greatest Cascade Lake published data. And then the other thing that we noticed that they did was they went out and they created 1-socket varieties in the Gold and Platinum series. And again, not really a competition in terms of overall performance. So from our perspective, when you look at how EPYC can apply in your environment, whether it's 2-socket or 1-socket, we think the vast majority of workloads, by the way, can matriculate to 1-socket. And the opposite works too. Now you can buy a 2-socket in your environment because you need it, because you need that scale, because you need that overall horsepower and performance. So at AMD, like I mentioned before, our focus is making sure that we're developing technology that is useful to you. My guess is many of you, if not all of you, live in a world of optimizing, deploying, managing the software side of infrastructure. The point here is that regardless of where you are, whether you're bare metal, hybrid, cloud, whether you're an app guy or an infrastructure guy, whether you're a management or administrative person, the reality is AMD has worked to develop technologies that range across the board. And not in a way that is A, proprietary, or B, blocks out the larger ecosystem. And that's an important distinction with us. When we look at the number of platforms that you can go and buy today, there's never been a broader portfolio of AMD platforms. I've highlighted some HP boxes here. Across the landscape, if there's an OEM that you work with, we're in their portfolio. In some cases, like with Dell EMC, we have the absolute latest and greatest flagship 1-socket, 2-socket, 1U, 2U systems that are only available on AMD EPYC. Same goes with Hewlett-Packard Enterprise. Not only do we have the platforms, but when you look at infrastructures of today, hyper-converged infrastructures, massive scale-out virtualization environments. We have ready nodes and tuned solutions, in this case highlighting Azure Stack HCI solutions that are offered by the likes of Hewlett-Packard and other OEMs, where you can just buy it, it is tuned and optimized and ready to run. And this is an important piece. It kind of bridges the gap between investing in a new technology. Yes, it's x86, but yes, you may not have AMD in your infrastructure today. And you need to make sure that from a mixed environment perspective, it's just going to work and run. The reality is we've taken all the guesswork out of it and tried to make it as easy as possible to take advantage of all the benefits that I talked about. And then couple that in a world where it's more common than not for data center environments to burst out to the cloud. So if you're bursting or if you're moving, if you've already migrated some of your infrastructure to Azure or another cloud provider, we provide instances in a broad range with them. So let's talk a little bit about the implications from a performance perspective. We talked about on-prem, hybrid, cloud. Let's start with bare metal. And it's Microsoft Ignite, for crying out loud. Let's have a SQL comparison here. So if you're looking at, again, this is top end to top end, but that tends to, at least give us an idea of what this would look like. The top end of the Platinum, the top end of the AMD EPYC stack, 2-socket to 2-socket, double the performance. Very, very nice scaling. And in point of fact, as we double the TPM, the transactions per minute, we are able to double the number of users per server. So very linear in its overall scaling. What this really results in is a much better solution as you're building and optimizing either per rack unit, per dollar spent, per dollar of OpEx that you have to rationalize over some period of time. So the reality is, from a bare metal perspective, we're seeing amazing performance and exactly what you would expect, given everything that I've already told you about what EPYC is. But then when we go a step further and we look at an environment or an infrastructure where, how does 1-socket play into this? What does 1-socket give us that could really change the game from an implementation perspective, even from an architecture perspective? So the DL325, the ProLiant DL325, was one of the first and broadest implementations of the AMD 1-socket capability. 16 DIMM slots, up to 64 cores, all the bells and whistles, all of the feature sets that EPYC brings to the table. When you look at it in the context of Azure Stack HCI, you can lower your overall cost. So this includes licensing. Now, what's interesting is there's debates in the industry right now around the impact of licensing and what that's going to mean to all of us. There are differences in licensing schemas depending on which provider you go with, in what configuration. Some of them have breakpoints in terms of the number of cores, and so this gets to be a bit of a Jenga game. But ultimately, what we did here is we compared against what you'd be buying otherwise. So instead of buying 3 servers with single sockets, you'd end up buying 3 servers with 2 sockets. And in point of fact, your licensing costs would be very, very similar. Your hardware acquisition costs, your operating costs would go down fairly dramatically. And so you add all of those savings up, and that's a third. That's a third of the savings that you can do today. And that's against the latest and greatest. My guess is you guys have N-1, N-2, N-, we won't talk about it, but no one has a perfectly either third and a third or a quarter every year refresh cycle. There's legacy hardware out there, and it's dragging down your overall OpEx. So when we look at what this capability can bring to bear, hardware-wise, acquisition cost-wise, it's very compelling. Think of what you could do with a third of your IT budget back, just as an idea. That's also before you think about the overall operational impact of deploying HCI in your overall environment versus using a traditional storage attach or network a stand. So when we look at this, not only can we give you more capability from an overall budget perspective, but we give you a heck of a lot more overall performance from an I/O perspective. So the implications go pretty significantly up and to the right in terms of what you can do with much less resource. And the other thing that I'd mention here, so we kind of have gone from an indication of performance bare metal, an indication of performance in the era of hyperconverge, and abstract everything, and take that the next step. Take that to the era of public cloud dominance, and this goes back to the ways in which we've been working very diligently with Azure and the entire cloud team to make sure that as we bring instances to market, they are providing value above and beyond what you can get from the competition. And this is a particularly difficult one, right? Because we're a chip that goes into a server that goes into a virtual instance. So there's got to be some there. And in point of fact, there is. Right? When we talk about the benefits of public cloud or even hybrid cloud for that matter, economics of scale become the primary concern. Can I get the level of economics of scale that are going to give me the return on my investment that is the promise of the cloud without sacrificing the performance capability that I have today in my on-premise operations? We're happy and extremely pleased to talk about the DAV4 and the EAV4 general purpose instances that are now in production with Azure. In fact, working with these guys, these are now the fastest general purpose virtual machines of their class. This is comparing against contemporaries who have like shapes, like instances in the industry right now. Azure really clearly out in the lead, taking advantage of not just a huge amount of CPU offerings from 2 to 96, very much targeted at general purpose or business class applications, to taking advantage of the memory intensive side of what AMD EPYC has to offer. I talked about the I/O, I talked about the Gen 4. Azure's done a really, really nice job of unlocking that for their customers. Both available in the East US and West US too, with the rest of the world rolling out this year. Very excited about the capabilities that these guys are bringing to the table, in addition to the full portfolio that you can take advantage of today with Azure. So kind of starting on the left here with the general purpose, I talked about the D and E instances, very balanced. These are at the heart of them, throughput machines. delivering amazing capability at incredible economics. HPC is one of the areas that AMD EPYC in its first generation really made tremendous headroads. So we've had a lot of public announcements around Department of Energy, various foreign governments that have taken on initiatives based on AMD EPYC technologies. And we're very proud to be working with the Azure team with their HBV2 instance. We had HBV1, and that's in preview. And it enables you to sign up for that right now or go out and kick the tires on HPV1. Again, one of the highest performance HPC public cloud instances on the planet. For GPU visualization, the NVV4, again, in preview, sign up today, but take advantage of the capabilities of the GPU, take advantage of the inherent capabilities of AMD EPYC and the performance that you get across the PCI Gen 4. And then, of course, when you've got the level of I/O throughput that EPYC has, we would definitely encourage you to take a look at LSV2 and the storage capabilities that you can get from a scale out and really amazing economic perspective. So let me talk just a little about choice. Choice is something that I didn't say it at the beginning. I could have titled the whole presentation, you have a choice. And the choice is not just AMD versus Intel, Azure versus the other guys. The choice is broader. The choice is relative to where you are in your workflow. Whether you're in manufacturing, whether you're in media and entertainment. I wanted to show you guys some examples of how the Azure offerings across the board can be applied. It's not a one-size-fits-all, and that, again, is the promise of the cloud, the ability to be very flexible in the way that you consume these instances depending on what you need. What you're seeing here in the white, orange, and blue columns here are variants across a workflow. So from concept to design to getting into simulation and analysis, an area where AMD has really led the industry, all the way through build and publication. There's a wide range of applicability of AMD EPYC, and I wanted to illustrate to you guys how important it is whether you're taking advantage of a fourth of a GPU in the NV8 or you're taking advantage of a full half of it in the design and visualization phase. You can slice and dice, and this is a great way to take advantage of the capabilities of EPYC without overburdening your system. This is the ultimate example of right sizing, and for a company who their lifeblood is getting through this process flow as fast as humanly possible. This is a critical element. It gets you there much more economically than you could have done with a standard on-premise implementation. Another great example, and we've seen. I don't know if you guys the reviews are mixed for this latest Terminator film. I think we've all seen a lot of Terminator films in our time, but a lot of the work was done on an AMD EPYC system. In media and entertainment, we're seeing more and more affinity towards taking advantage of the core scaling and the memory bandwidth of AMD EPYC. And this workflow is a good example of how across the board you can consume different Azure instances and really dial up and down the resources as you need to and as makes sense for your environment. So again, from full GPU capability to taking advantage of the HP V1 core scaling, memory bandwidth ratios, you have the recipe now at the drop of a hat to deploy, apply to your workload, and unlock some amazing capability. So very proud of the way that within industries we're starting to see EPYC take hold. So I want to leave you with a couple of thoughts, and then I'll entertain any questions you have. But I showed you the performance charts for a reason. You look at the capabilities. We're not talking generation over generation. We're talking about a new standard of capability. So when you're thinking about what you architect, when you think about how you're rolling it out, think about the implications of taking a third of the cost out of your environment today, maybe a half. maybe 75% if you're moving out old gear, N-2, N-3. Maybe you're removing that sand out of your environment. The reality is no one's going to be able to touch the price performance of the systems that are based on AMD EPYC. We also want to be and are, from a partnership perspective with Microsoft, at the forefront of modernizing the data center. So whether that's deploying hybrid cloud infrastructures, whether that's really taking advantage of HCI as a capability, it's extremely important in the way that we not only think about the processor and the chip, but it's when the chip becomes more than a chip. And that is when we unlock the power with partners like Microsoft. And in point of fact, I mentioned this earlier, AMD is not driving a strategy of building proprietary technology and locking the ecosystem out. It's an embracing strategy. And so, the industry adoption, whether it be hardware devices, ISVs, and customers doing amazing things either in the cloud or on premise. We're very excited about what EPYC can mean to you and your environment and capabilities as you move forward and build that modern data center. So with that, let me pause and see if there are any questions. And if not, I'll just start into my interpretive dance. Yes, sir. So 16 is the first step beyond 8. So we've got 8, 16, 24. You've got, I want to say, 2 16-core options with slightly different frequencies, same feature sets across the board. Was there something else to your question, or? Okay. Yeah. Keeping it simple, we just created the breakpoints we did, but yeah, definitely 16 and 24 are options in the EPYC stack. Yes, sir.
Are there any data sheets or anything for using EPYC in a VDI environment?
In a VDI environment, yes. We've got some information we can get to you. Our booth is the best place to get to that. When you go in the main hall, you hang a left, kind of angle back, and you'll see us. White booth, AMD all over it. Thank you. Do you have another one? Go for it, man. Yeah. So we're non-denominational when it comes to VDI infrastructures. We want to play with everybody. From like a reference architecture perspective. Actually, I'm not sure if we have a Citrix. Does anybody know if we have a Citrix reference architecture available? I think we've got them for the other varieties. But that's one where we could probably take something we've got and give you enough information to start down that path. There's one element that I didn't mention that sets us apart a little bit. The competition's trying to keep up. Obviously, we're here today talking about multiple product lines. We've got a full and robust line of laptop and desktop processors. But we also have both consumer and commercial GPUs. And so in the context of VDI, a lot of times that's a part of the conversation as well. And we've got experts here this week that can talk you through VDI solutions based off of Radeon technologies as well.
As far as availability, you said end of 2019 you expect worldwide release of the D and the E series.
Mm-hmm.
Are you saying that's going to be right at the end of the year? Or are we talking about rolling out right now and we should check our marketplace?
Let me get the real version of that. Can we say anything more specific than by end of the year?
I don't believe we can, but definitely be looking out for announcements next month.
Yeah, maybe like. That's available now. Yeah. Thank you. Other questions? All right, my gift to you is I won't break out into interpretive dance, but thank you all very much for being here. Again, Thursday at Microsoft Ignite. I know how difficult it is to get into these. I'm going to be here for a while. If you have any other questions, I would love to talk to you personally. Otherwise, enjoy the rest of your show and travel safe heading back to wherever you're from. Thank you very much.